Today in the lab, we're looking at how closed-loop step motor systems outperform traditional open-loop step motors in terms of torque. To demonstrate that, we've got two equally sized step motors. On the one hand, we've got a conventional motor that will drive open-loop with a basic microstepping drive. On the other hand, we've got a StepSERVO closed-loop integrated motor. As we compare these two motors side by side, we can see that they both have an EMA 23 frame size, and the stators, which are the torque generating portions of the motors, are the same length. They have the same windings, so they will essentially perform the same, except that this motor is being driven open loop and this motor is being driven closed loop. So to show us how this test is going to work, Matt will explain it. Matt?
I'm back here.
So come on over here and show us how this works.
Okay, sure. The way this test works is that each motor will be commanded to make identical point-to-point moves. In these point-to-point moves, each motor will accelerate to a fixed velocity, run at that velocity for a brief period of time, and then decelerate to a stop. Throughout these tests, the target velocity will be 10 revolutions per second, or 600 RPM. With a moderate acceleration rate of 100 revolutions per second squared, we can see that both motors perform this move just fine. Now we increase the acceleration rate to 500 revs per second squared and observe what happens. As you can see, the open loop motor is starting to lose steps. This is happening because the open loop motor does not have enough torque to accurately accelerate and decelerate the motor at this higher rate. However, we can also see that the closed-loop StepSERVO motor continues to accurately position with this more aggressive move profile. In fact, we can increase the acceleration rate all the way to 2,500 revs per second squared, and the StepSERVO motor continues to position accurately. Meanwhile, the open loop has nowhere near enough torque to complete this move. The reason the StepSERVO motor can do this is because of closed-loop servo control, which allows the motor to generate peak torques as much as 50% higher than the open loop motor. Another thing to notice in this test is that with the increased acceleration rate, the move time of the StepSERVO motor is much shorter. Depending on the target velocity, the closed loop motor will decrease move time by as much as 40% or more. In simple terms, a shorter move means more cycles per minute and greater throughput for your machine or process.
So there you have it. If your machine or process requires more torque, higher acceleration rates, greater throughput, it's time to upgrade to StepSERVO. Thanks for watching, and see you next time inside the lab at Applied Motion Products.